OK, the final type of intrusion detection system, the final place you can put one of those systems, is not quite in the picture from earlier, but the idea has to do with logging. So nowadays, most modern servers and computers usually have logging systems. In other words, when interesting things happen, they will usually write down that event in some sort of log. And that's just a big text file with a big archive of all of the interesting things that have happened. So for example, if a user decides to access the server and log in, then maybe the server writes down that at this time, this user logged in, and it worked. Or maybe if an error happened, we will go to the log, and the server will write down that at this time, an error happened, and this is what we did to respond to it. So if we already have these big text files that these systems are generating that list out all of the interesting events that happen, what if we just took this text file and read it to understand what attacks might have happened? That's the idea behind logging. So as an example, maybe every night when the servers are going to sleep and every employee has gone home, we go to all of the servers, we download their logs, we get those big text files with lists of events, and we just run some script on that text file to see if it has any attacks written down. So this could be as simple as a Python script that just reads the contents of a text file and outputs what attacks happened. So we're not doing anything too complicated here. We're just reading a text file and seeing what it says. Possibly it has some evidence of an attack. That's basically the idea behind logging. Here are some benefits. One, it's pretty cheap. Modern web servers already do this. So you usually don't have to tell systems to generate logs. They already do so by default. And we usually avoid most inconsistency problems because the logging system is the end host. So whatever the end host interpreted is the same as what they write down in the log. It's not two different people trying to process the same input. The end host processes the input and generates the log. So we can see exactly how the end host interpreted the input. Those are some benefits. Here are some drawbacks. One major drawback that the other two detection systems didn't have is that you can't detect things in real time. So earlier, with NIDS and HIDS, they were active pieces of software running on the computer. So if an attack happens, the NIDS can see the packet and immediately flag that an attack is currently under progress. Or the HIDS can notice that the computer is under attack and immediately alert that the attack is under progress. However, with logging, you don't get that because the log is only generated after the event happened. So if a user logs in, only after they log in do we write down that it happened. So by the time you go and run the script and read what the log has generated, all of the events in the log have already happened. So there's no way to detect the attack in real time. You usually have to wait until after the attack happens to go back and read the logs and notice that they have happened. So there's a bit of a delay that doesn't occur in NIDS and HIDS. Once again, there are still some evasion attacks. And one more problem is that the attacker could change the logs to erase evidence of the attack. So maybe if the attacker hacks into the system, they could also go and delete the log file so that all evidence of their hack has been deleted. And that's something that logging would have trouble detecting.